In this introduction video, we are going to compare classical AI coding agents and AI code. Let's get started. AI coding agents can generate and maintain apps from simple prompts. Here is an example. Create an app that browses the pictures on a smartphone and categorizes them. For each image representing mainly a person, tag it as friends. For each image representing mainly a landscape, tag it as holidays. All others tagged uncategorized. The app must be installable on Android and iOS. As a direct result of the prompt, the AI coding agents will generate a complete application, immediately and automatically. AI agents are intuitive and simple to use. They are fast, very powerful, and useful. They are very efficient for creating simple applications, but also functional prototypes allowing to showcase a concept and raise funds for a startup. Some companies are even already using them to develop enterprise applications, but we don't have a lot of perspective on the result of these experiments. Because you should know that AI coding agents have inherent defaults, especially if you want to maintain the AI-generated applications in the long term. The AIs produce low-grade software architectures. This will create technical debt that will prove expensive in long-term maintenance. The AIs are very focused on microtasks, which is very useful usually. But when applied to software engineering, narrow focus on a task can break another functionality or core invariant somewhere else in the codebase. The AIs will prove correct anything with unit testing, even broken code. Finally, the AIs don't remember important concepts and traps hidden within the code. Whereas a human developer in a classical team is very well aware of a specific project's constraints. Overall, the quality of the code generated by an AI is inferior to the quality of the code written by a human team of specialized developers. Now, could we imagine a new hybrid solution? This solution would benefit from the incredible speed and vast generic knowledge of an AI. At the same time, a competent human developer would be in control of the architecture and provide project context and memory. The best of both worlds. The solution would of course be slower and more complex than AI coding agents, but still way faster than programming without the help of an AI. It would be a sort of compromise, something in between. Most importantly, the solution would allow a developer to use AI to create and maintain large enterprise applications efficiently in the long term. To solve this problem, someone has invented a strict AI software engineering methodology and embedded the methodology in a software. This software's name is AICode. AICode is an AI coding assistant based on ChatGPT and distributed as a Visual Studio Code extension. AICode was specifically designed to provide a solution for the long-term maintenance problem of AI-generated code. It solves this problem by inducing a tightly intertwined collaboration between the developer and the AI at every step of the development. During ideation, when exposing the task to the AI, there is an interactive conversation leading to a mutual understanding. Before coding, the AI produces a detailed specification that the human developer can inspect and fix before any line of code is written. This specification can be refined by the AI, meaning the AI will reprocess it several times before and after coding. For complex work, this multi-pass workflow dramatically improves quality by reducing design mistakes, catching edge cases earlier, and lowering the overall bug rate. And when the code is generated, the human developer can and must inspect each code patch, file by file, and approve it manually. In addition to this strict human-controlled workflow, AICode has powerful AI features such as a multi-dimensional project index, allowing the AI to search related code and documentation in every way possible. Powerful AI tools such as Git history, internet search, screenshots vision, files upload with retrieval augmented generation, MCP connectors, and more. Also, AICode's interface is very user-friendly, purely graphical, and totally integrated within Visual Studio Code. Now let's see this methodology in action. It's time for a demo. This is an example of an authentic chat session with AICode to build a feature called Context Size Indicator. It begins with a sophisticated prompt written by a developer, which describes the task with as many details as possible. It also includes some uncertainty, verbalized, while requesting AICode to search factual answers in the code base. There are also some technical and logical constraints. The developer sends the prompt now. AICode inspects the code base and replies with a restatement of the request to make sure both minds are aligned. It provides a technical analysis of the task. It also gives the missing information requested in the developer's prompt. It answers point by point with simple yet accurate language. In Part 10, AICode underlines key missing elements from the developer's prompt and suggests solutions. It concludes with a list of questions and a summary of its message. Then the developer follows up with the responses to the questions and additional constraints. AICode inspects the code base one more time, following the developer's angle. He replies with targeted details. In the next messages, the developer and the AI solve their disagreements by the means of technical negotiation. The ideation phase ends with they both agree on everything. The developer requests a specification. AICode inspects the code base one more time and produces a specification based on all the demands of the developer during ideation. The developer reads the specification and decides to have AICode check it and also modify it with new constraints. Make sure your context size simulation includes the system prompt, the tool's definitions, and everything, as in a real simulation. Write it in the spec so there is no ambiguity. AICode's interface generates a refined prompt text and copies it to the clipboard. The developer pastes this generated prompt back into AICode chat text area and sends the query. The AI inspects the code base and replies with a better specification, including the change requested by the developer, but also some fixes for mistakes the AI has detected during this second pass of analysis. It also outputs a list of the changes to help the developer, so he doesn't need to read the whole specification again. The developer requests another refinement, with new constraints about the modularity of the new code. The AI complies. Again, it produces a better specification and a list of changes. The developer decides to refine one more time. He can do it as many times as he wants, each refinement making the specification more correct. The AI complies. Then the developer decides the specification is good enough after 3 refinements and commands AICode to produce the code. The AI inspects the code base and produces the new code, file by file. The developer reviews and accepts the changes. After coding is finished and the developer has accepted the changes, he decides to verify if the specification is implemented fully and correctly. So the developer requests a verification to AICode. The AI inspects the code base and produces an audit of the implementation of the specification. It finds minor optional adjustments. The developer accepts them. AICode will produce the adjustments. The full AICode workflow has been executed. Ideate, specify, refine, code, verify. The feature is implemented. The developer can stage and commit. After seeing the workflow applied on a real-life example, we can make sense of it. Interactive ideation consists of conversational follow-ups, answering the AI's questions and adding constraints, and also asking the AI to search the code base for factual answers about the current implementation. The detailed specification generated by the AI is a markdown artifact, used as a key reference document, allowing the human developer to detect mistakes, ambiguous demands, and misunderstandings with the AI. And all these imperfections can be addressed by the developer by refining the specification with additional instructions. The iterative error detection is inexpensive from the developer point of view because it is performed by the AI during the refine and verify phases before and after coding. And the AI systematically outputs detailed conformity and error reports as the smooth communication between the developer and the AI is paramount. The files are modified by the AI through a virtual file system, so they will always be edited manually by the developer. Unlike automatic agents, AI code makes it extremely important and even mandatory to have at least a quick look at every file update before writing anything on the disk. Let's summarize the methodology used by AI code to combine the power of the AI and the intelligence of the human developer. The first step is ideate. The developer explains the task to the AI. The AI replies with an analysis and questions, and the conversation continues until both parties converge. The second step is specify. From the ideation phase material, the AI generates a formal specification, allowing the developer to detect and fix misunderstandings with the AI. The third step is refine. It consists of a loop of AI integrity checks of the specification against the real code base. Each refinement detects more errors early, right before coding. The fourth step is code. The AI generates the file's modifications from the refined specification and writes the changes in a virtual workspace. The developer receives the code as proposals and is the only judge of what is worthy of integration in the code base. The fifth and final step is verify. The AI audits the newly integrated code against the specification. If something is not compliant, it is detected, and the AI proposes adjustments that the developer can accept or decline. This structured methodology makes it feasible to program using the assistance of an AI, while a human developer guarantees a solid software architecture and a high code quality, because he always stays in control. This is how AI code can assist the developer in creating and modifying large enterprise applications that can be maintained in the long run. AI code is a powerful and complete solution. It includes many other features, such as a native AI-assisted debugger, code reviews of pull requests loaded from Git, GitHub, Jira, or any cloud provider supporting the MCP protocol, a set of system instructions rendering the assistant honest by design, interface buttons allowing to backtrack from any point during chat sessions, several procedures to export and share context between sessions, a native procedure allowing to split large files with minimal regression, a bring-your-own API key mode for maximum private data ownership. Finally, AI code is designed offline first, meaning it stores the index data and conversation history on your local drive for maximum private data security.